Embark on an astronomical odyssey as we voyage through the depths of our solar system in a quest that challenges everything we thought we knew. Join us in the exhilarating video that unveils the enigmatic riddle of the search for Planet 9. Prepare to be captivated by the mysteries of the unseen as brilliant minds decipher the celestial whispers and unveil a hidden world that could forever redefine our understanding of the cosmos. Brace yourself for a cosmic journey that will leave you in awe and with the burning question: what secrets lie beyond the edge of our known solar system? Planet 9. Planet 9, also referred to as Planet X, is a hypothetical planet that is believed to exist in the outer regions of our solar system beyond the orbit of Neptune. Its existence is currently based on indirect observations and mathematical models rather than direct observation. The concept of Planet 9 emerged as scientists noticed peculiarities in the orbits of some distant objects in the Kuiper Belt, a region of icy bodies beyond Neptune. These objects seem to be influenced by the gravitational pull of an unseen massive object. Scientists hypothesized that this mysterious gravitational force could be attributed to the presence of an undiscovered planet. The potential characteristics of Planet 9 are still uncertain, but it is thought to be a gas giant with a mass several times that of Earth. It is postulated to have an elongated orbit that takes it on a highly elliptical path, making it difficult to detect using current telescopes. Efforts are underway to search for Planet 9 through large-scale sky surveys and analysis of existing data. Scientists are studying the gravitational effects it may have on other celestial bodies, the patterns of its potential orbit, and its potential origin in the early solar system. History. Following the discovery of Neptune in 1846, there was considerable speculation that another planet might exist beyond its orbit. The best known of these theories predicted the existence of a distant planet that was influencing the orbits of Uranus and Neptune. After extensive calculations, Percival Lowell predicted the possible orbit and location of the hypothetical trans-Neptunian planet and began an extensive search for it in 1906. He called the hypothetical object Planet X, a name previously used by Gabriel Dallet. Clyde Tombaugh continued Lowell's search and in 1930 discovered Pluto, but it was soon determined to be too small to qualify as Lowell's Planet X. After Voyager 2's flyby of Neptune in 1989, the difference between Uranus' predicted and observed orbit was determined to have been due to the use of a previously inaccurate mass of Neptune. Orbit. Planet 9 was initially hypothesized to follow an elliptical orbit around the Sun with an eccentricity of 0.2 to 0.5, and its semi-major axis was estimated to be 400 to 800 O, roughly 13 to 26 times the distance from Neptune to the Sun. It would take the planet between 10,000 and 20,000 years to make one full orbit around the Sun, and its inclination to the ecliptic, the plane of the Earth's orbit, was projected to be 15 degrees to 25 degrees. The aphelion, or farthest point from the Sun, would be in the general direction of the constellation of Taurus, whereas the perihelion, the nearest point to the Sun, would be in the general direction of the southerly areas of Serpens, Caput, Ophiuchus, and Libra. Brown thinks that if Planet 9 exists, a probe could reach it in as little as 20 years by using a powered slingshot trajectory around the Sun. Mass and radius. The planet is estimated to have 5 to 10 times the mass of Earth and a radius of 2 to 4 times Earth's. Brown thinks that if Planet 9 exists, its mass is sufficient to clear its orbit of large bodies in 4.5 billion years, the age of the solar system, and that its gravity dominates the outer edge of the solar system, which is sufficient to make it a planet by current definitions. Astronomer Jean-Luc Margat has also stated that Planet 9 satisfies his criteria and would qualify as a planet if and when it is detected. Origin. Several possible origins for Planet 9 have been examined, including its ejection from the neighborhood of the known giant planets, capture from another star, and in situ formation. Badigan and Brown proposed that Planet 9 formed closer to the Sun and was ejected into a distant eccentric orbit following a close encounter with Jupiter or Saturn during the nebular epoch. The gravity of a nearby star, or drag from the gaseous remnants of the solar nebula, then reduced the eccentricity of its orbit. This raised its perihelion, leaving it in a very wide but stable orbit beyond the influence of the other planets. The odds of this occurring has been estimated at a few percent. Had it not been flung into the solar system's farthest reaches, Planet 9 could have accreted more mass from the protoplanetary disk and developed into the core of a gas giant. Instead, its growth was halted early, leaving it with a lower mass than Uranus or Neptune. Orbits of high-inclination objects. A population of high-inclination TNOs with semi-major axes less than 100 AU may be generated by the combined effects of Planet 9 and the other giant planets. The ET-nanos that enter perpendicular orbits have perihelia low enough for their orbits to intersect those of Neptune or the other giant planets. An encounter with one of these planets can lower an ET-nano's semi-major axis to below 100 AU, where the object's orbit is no longer controlled by Planet 9, leaving it in an orbit like 2008 KV42. The predicted orbital distribution of the longest-lived of these objects is non-uniform. Most would have orbits with perihelia ranging from 5 AU to 35 AU and inclinations below 110 degrees. Beyond a gap with few objects would be others with inclinations near 150 degrees and perihelia near 10 AU. Previously, it was proposed that these objects originated in the Oort cloud, a theoretical cloud of icy planetesimals surrounding the Sun at distances of 2,000 to 200,000 AU. In simulations without Planet 9, an insufficient number are produced from the Oort cloud relative to observations, however. A few of the high-inclination TNOs may become retrograde Jupiter Trojans. Oort cloud and comets. Planet 9 would alter the source regions and the inclination distribution of comets. In simulations of the migration of the giant planets described by the NICE model, fewer objects are captured in the Oort cloud when Planet 9 is included. Other objects would be captured in a cloud of objects dynamically controlled by Planet 9. This Planet 9 cloud, made up of the ET-nanos and the perpendicular objects, would extend from semi-major axes of 200 AU to 3000 AU and contain roughly 0.3 to 0.4 Earth masses. When the perihelia of objects in the Planet 9 cloud drop low enough for them to encounter the other planets, some would be scattered into orbits that enter the inner solar system where they could be observed as comets. If Planet 9 exists, these would make up roughly 1/3 of the Halley-type comets. Interactions with Planet 9 would also increase the inclinations of the scattered disk objects that cross its orbit. As the mesmerizing journey through the vast reaches of our solar system comes to a close, we are left in awe of the tantalizing quest for the elusive Planet 9. The video has whisked us away on a celestial adventure, fueling our curiosity and igniting our imagination. We find ourselves peering into the depths of space, longing to catch a glimpse of this enigmatic world. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.